All right, sounds good. So my name is Abel Shifarao, and I'm originally from Ethiopia, and have a background in interdisciplinary areas. I started out as a in by training in economics and financial engineering. I did both my master's and undergrad education in these areas. And I would say pretty much a self-taught data analyst and data engineer, data scientist. Uh, I'm sure most of you are in college right now studying computer science or something similar to break into the tech career. The traditional university system, college, and so on, still important, but it's also possible to break into tech career was self-studies. That's how I did it. Even though economics and finance have a little bit some overlap with data analytics, but it's not completely the same, or it doesn't have the same technical components to it. And then I started out as a data analyst at a SaaS, software as a service startup company, and later worked for companies, big tech companies like Google, Amazon, Pfizer, and now I'm currently a data analytics engineer at Meta. So I'm going to go through what I do as a data analytics engineer or as a data engineer, and how the data space is like, or the data landscape, specifically in the US job market, and what data analysts in general use, what technologies, tools, and programming language they use, and so on. And also, if you are interested in getting into uh, the data space, then what exactly should be learning and what career path you should be following. So I'll cover all these things within 20, 25 minutes. That's how much time I have for this presentation. So I'll try to be as concise and brief as possible. So as a data analyst, uh, in general, as a data analytics engineer, not specifically at Meta or anything, in general, I usually work with raw data and building infrastructures and transforming the raw data into analytics ready models for reporting purposes. And I build and maintain data pipelines. Data pipelines are the pipelines that we use to move data from different sources, various sources, into a destination warehouse, after which from which we can use for various purposes, for analytics, for business intelligence, for data science, AI, machine learning, and so on. So the data sets have to be ready first, and one single central location for it to be available for this kind of purposes. So data analytics engineers or data engineers build these pipelines, and also enabling self-service analytics and reporting. So as data analytics engineer, I keep saying this, but data engineer and data analytics engineer are a little bit different. Analytics engineers also work on the analytics and reporting side of things, building the infrastructure and the self-service capabilities for data to be used for final decision making. So I also work on that side of the data process. So the tools, technologies, and languages I use include language, SQL, and Python. SQL is a bread and butter of data, as you all know. Without SQL, you cannot do anything in the data space. So I use SQL and Python. Python, of course, one of the most versatile and most commonly used programming language, not only in data, in many different tech spaces as well. And in data specifically, it's highly in demand, and it's very, very crucial programming language as well. So version control, GitHub, and ETL, ALT tools like Fivetran, Matillion, Stitch, dbt, Airflow, and Kafka for real-time streaming data, and cloud platforms, Snowflake Data Cloud, which is very increasingly becoming very popular big data and data housing solution right now, and Azure Cloud, AWS Cloud, and tools, services, and tools that are specific to the data space in these clouds. So these are generally what I use, regardless of the role, the company, and title I have throughout my experience. But at Meta, things are a little bit different. In general, if you're working for big tech companies, they tend to use very specific uh, uh, internal tools that are not publicly available. So it may not be really useful to mention those things. That's why I purposefully avoided mentioning internal tools, because they're not really industry standard tools. So in terms of BI, Power BI, Tableau, Looker. So Power BI and Tableau are the industry leaders in terms of BI solutions. In terms of BI solutions, and Looker is also an up and coming cloud-based BI tool or business intelligence tool. So what are the career options for one to get into the data space? What are the options or the career paths available? So from my experience and the industry, you can choose roughly 3 different options or 3 different routes to get into the data space as a career option. The data engineering path, or data analytics, or data science, but they are not mutually exclusive. DE or data engineers, they usually build and maintain the data infrastructure and the pipelines. They are in charge of moving data from sources into destinations and building the models and transforming, cleansing them, and making the data sets ready for reporting purposes. If you are a data analytics engineer, then you are responsible, in charge of for all these things, plus building the BI and the self-service reporting, dashboarding side of things as well. As a data analyst, it's a little bit a narrower scope. You only focus on exploring and interpreting data to generate insights and create KPIs and metrics that are going to be used for decision making. So once the data is ready and available in the data house, and mostly built by the pipelines and the infrastructures built by the data engineers, and the data analysts take it from there and then build the insights and KPIs and metrics and so on, so that stakeholders and management and various decision makers in a given business leverage it to make critical business decisions. And data science, again, is there used interchangeably nowadays in the industry, data analysts and data scientists and so on, but they have subtle differences when it comes to responsibilities and overall role in the data lifecycle. So data scientists usually use models and statistical processes, and they engage in predicting trends, and they use predictive analytics and also machine learning and AI to predict outcomes based on past trends. So this a little bit broader in scope than the data analytics or data engineering. So given this background as to what career options you have in the data space, and the understanding the current data landscape and the technologies and the solutions that are becoming very common in the industry standard right now is very crucial. So the current landscape is changing. The data landscape is changing because there are technologies and AI and the cloud and so on that are being introduced in a very exponential speed. So from what we're being familiar with back in the days compared to what is the industry standard now, there are some major changes. One everything is becoming more on the cloud. So everything on-prem tools, databases, and transformation tools, BI and analytics are being done on the cloud. And ETL processes, which means extract, transform, load, is being replaced by ELT processes. So ELT, extract, load, and transform. I'll explain why, because this is a very important transformation or shift in that in the data landscape. Following the shift from on-prem to the cloud, we are able to tap into very powerful processing and very powerful resources like massive parallel processing and so on. So that means we can do all sorts of transformation, data cleaning, and very resource intensive data analytics on the cloud itself, on the data house, without needing to use ETL tools that we've been using before back in the day, SSIS, and so on, various on-prem and ETL based pipelines. So instead of extracting the data, transforming it before loading it into the data house, nowadays the most common approach, what's becoming the most common approach, is extracting the data first from different sources, directly loading it without doing any transformation, without having to do any cleaning and transformation, loading it into the destination warehouses. It could be on AWS cloud, it could be on Azure cloud or Snowflake data cloud, and then doing the transformation in the data cleaning, the modeling, once it is on the data, because the data houses that are on the cloud right now, they have very powerful capability to do all this transformations on petabytes of data. So this is made possible because of the cloud. And the other shift is the other shift in the data landscape is manual deployment is becoming a thing of the past right now. So writing queries or building reports and then manually delivering them and scheduling and manually monitoring them is becoming a little bit obsolete right now, because even data analysts and data engineers are leveraging CI/CD processes as software engineers or software developers, following the software development lifecycle, what we call the ADLS. So if you are aspiring to become a data analyst or professional in the data professional, CI/CD is now being a very important skill sets. You don't have to be a software engineer or software developer to be required to know CI/CD processes. CI/CD stands for continuous development and continuous integration and continuous deployment. And the fourth one is batch jobs. Batch process data and batch jobs are being replaced with tools and solutions with capabilities for real-time and almost near real-time processing. So right now, we're not only dealing with batch process data. We're making decisions in real time. So we're using real-time clickstream data to analyze and make decisions about our business and various aspects of our decision-making processes. So this being said, the modern data stack has also changed along with this change in the data landscape. In terms of the data ingestion, ELT tools, we are now dealing with more, like I said, ELT approach. So the tools have also changed. Back in the days, it used to be SQL Server Integration Services, Informatica, and so on. These are ETL tools, which are capable of extracting data from different sources and doing all the transformations required and loading them to destination warehouses. But right now, with the cloud and powerful data houses, we don't need this kind of tools. We need ELT tools or data loaders like Fivetran, Stage, and so on. So we have to switch our focus into this tech stack if we are aspiring to become a data analyst in the modern data landscape. And data storage and warehousing has also shifted from on-premise databases like SQL Server, on-premise Postgres or MySQL to more cloud-based and fully managed data houses, Snowflake, BigQuery, Databricks, Redshift, and so on. And transformation and modeling tools, especially was becoming very industry standard data modeling and data transformation tool is DBT, data build tool. It's becoming very popular. It's recently it's an up and coming tool, but becoming very common industry standard in the data space. So DBT and along with streaming and data streaming and transformation tools like Kafka are becoming very common in the modern data stack right now. And orchestration and workflow management tools like Airflow and various tools are now becoming very common compared to the traditional data stack. So in terms of the analytics and data governance as well, the tools and the solutions are shifting a little bit towards more cloud-based solutions as well, which are Looker, cloud-based BI tool, again, Tableau, which has capabilities for transformation and building models on-prem and publishing it and sharing it, sharing insights and self-service dashboards on the cloud, and Power BI the same, and data governance and data cataloging tools like Elation and Atlan and so on. And machine learning, AI platforms, and version control and DevOps as well. So version control and DevOps, GitHub, Git are a must tool in that modern data stack. And knowing DevOps, like I mentioned before, everything is done in CI/CD approach instead of batch processing. So learning and knowing DevOps tool and version control tools is a must right now in the modern data stack. So as aspiring data scientists or data analysts or data engineers, where should you get started? So from my experience over the last 8 years in the data space and from the industry standard and how the data landscape is going right now, I would highly recommend starting out with SQL and Python as a programming language. Like I said, SQL is a lingua franca of data. You cannot do anything with data without using SQL. So you have to be expert at SQL and Python as well, especially if you are aspiring to grow as a data professional, and mid-level and senior level positions require Python as much as SQL. So from Python, as you all know, Python is a general purpose programming language, can be used for all sorts of different purposes, including scripting, web development, and AI and machine learning and so on. But you have to narrow your focus if you are to become a data analyst, or data engineer. Only focus on the packages and libraries that are relevant to your career goal. So I would say as data professional, focus on Pandas, NumPy, and Matplotlib, Seaborn, and so on, this kind of packages. And databases and data housing from traditional on-prem solutions, databases, Postgres is really still popular. Focus on Postgres or any major on-prem databases like Microsoft SQL Server, MySQL, and so on. They have cloud version as well, but you can just learn the on-prem versions. And on the cloud, Snowflake Data Cloud Data House solution is one of the most popular ones. So you should learn one of the cloud-based data house solutions, either Snowflake, Redshift on AWS, or Azure Synapse on Microsoft Azure. But my personal favorite, which is also very beginner friendly, big data or cloud data solution, is Snowflake. And as a bonus, Databricks and Spark are one of the most popular big data tools in the market right now. So you can include those as well. And version control, Git and GitHub are a must. So without version controlling and working collaboratively with a team using these tools, you cannot grow as a data professional at all. And data modeling and ETL tools, you should focus on a few tools like Matillion or Fivetran, which are ELT tools. Like I mentioned, we're no longer using ETL tools. At least in the US market, everything is shifting towards data loaders or ELT tools that only pick the data from sources and load it into the destination warehouse. These tools are Fivetran, Matillion, Stage, Airbyte, and so on. But the most popular ones in the US job market are Fivetran and Matillion, and you can learn either one of them. And Airflow is data orchestration, scheduling, and monitoring tool, which is open source, built by Airbnb engineers. So learn this because most companies use this for orchestration and scheduling of different data jobs, data tasks, and ETL processes. And as a bonus here, also Kafka is open source data streaming tool, and ADF or Azure Data Factory and AWS Glue are also important skill sets to add into your toolbox. And DBT, as I mentioned, is very popular and high in demand skill set in the data space right now. And in terms of data visualization and BI, as a data analyst or even data engineers, which are in charge of only the pipeline side of things, moving data from sources to destination and building models, cleaning the data, transforming it. But they are also can be in charge of the BI side or the visualization side of the data to make it more convenient for decision making. So you need to know either Power BI or Tableau for building reports and dashboards and visualizing the data, and also the good old spreadsheet tools like Excel or Google Sheets. And as finally, if you are aspiring to become a data professional, you should have a specific goal and follow specific path to be successful. From my experience, I would highly recommend you start out with more easier and narrow in scope approach with data analytics or BI development, because this career or role only focus on specific and limited number of tools and technologies and programming languages. You can be expert and expand on the skill sets within a short period of time. You can start out as a data scientist or as a data engineer, but it could be very overwhelming and daunting, so much so that you may even be discouraged or frustrated without getting anywhere in your career. So I would really recommend starting out with data analytics or BI and so on, easier stepping stone. And then you can grow into a data engineer adding various big data solutions, ALT tools, data loaders, DBT, and so on, data transformation, data modeling, system design, and so on. And then finally go to data science and machine learning, AI, and so on. So we can, like I said, directly go into machine learning or data science and so on. But starting out at such higher level would be a little bit frustrating and daunting. So this is a career path I would recommend. This is pretty much all I have to share with you. If you have any questions or comments, or you want to reach out and connect with me, you can find me here. My LinkedIn and my email addresses, my email address are listed here. And thank you so much.